Hello guys, welcome to OS Project D16A. Today we're gonna to discuss about the CPU scheduling part. We got totally 4 members in this team. This is me, Yeoh Ming, and the second is Xuan, the third is Chen, and the fourth is Shen. So we're gonna to discuss about the non-preemptive priority, which is also the subtopic of the CPU scheduling. As you can see that here is a table is showing the 5 processors and their own arrival time in MS, burst time in MS, and their priority. In non-preemptive priority, you have to know that we use the ascending order of priority number as value also to determine the order of the processors. So as you can see that we also put P1 before P2, although the P1 priority is larger than P2. Why? It's because that arrival time of processors 1 is 0 here. So we have to put the 0 ms arrival time as the starter of the solution. So which means that the 0 here is also become the response time of the P1. Then the problem is how do we calculate the P2 response time here? So maybe we have to use the P1 response time 0 plus with the P1 burst time here, which is very 8, to get the P2 here, the P2 response time. Then it's the same also, we use P2 response time 8 to get the P4 plus with the P2 burst time 5 to get 13, and then 13 response time of the P4 to plus with P4 ons burst time to get P3, and P3 response time 16 plus with 10 of its burst time here, and then to get the P5 response time, and the totally will be 32 after we use P5 response time 26 to plus with the 6 of the P5 first time here. So we get 32 totally, and then we got to calculate the waiting time in the non-preemptive priority. The waiting time is calculated by response time minus arrival time. So P1, we get the 0 response time minus with the its own arrival time because we put arrival time as started to get the response time of P1, right? So 0 minus 0 is also equals to 0. So P2, we get the response time 8 after we add with the P1 response time with the arrival with the burst time of P1. So we get 8 totally to minus its on P2 is on arrival time. Remember response time is you use the response time of itself, the P2 itself, like example P2 itself, response time, so minus with the arrival time itself. So P3 is 13 because 16 minus 3, P4 8 because 13 minus 5, and P5 is 26 minus 8 to get the 18. So we also have to calculate the average waiting time, which calculated by the waiting time minus of the number of processors, which means that if you today in the table you got like totally 6 processors, you have to divide it by the 6 here is replaced by 6 here if there are 6 processors in the table, and the waiting time for P1 is 0, P2 is 6, P3 is 13, P4 is 8, and P5 is 18. So we get totally 45 here to divide it by 5 to get the average waiting time, which is 9 ms. Remember, the waiting time, average waiting time, and all of the response time, burst time, and arrival time is in the ms unit. So this is our end of the part today. Thank you.
Hi guys, I am Chen I'm from session D16A. Today I will present the preventive priority. The two main point when you do this priority is the first is use which process arrival first, and the second is process terminate. Now, this is an example for our question. First, our arrival time is zero, right? The arrival time is zero. So we must use the P1 to make our first one because another one, the process is haven't come yet. So the first one is P1. So the P1 you must write down lah, the burst time and the priority. The first time and priority. Priority you can use the bracket. Now, why this one write 2? Because the second arrival time is 2 lah. So we write down the P2 at here, the burst time and the priority. And then the P1 at the latest one, at the first 0 until 2, we must minus lah, become 6. And the priority is the same lah. And we compare which one is the smallest one priority. These two. The one is the smallest, right? So we write the P2 as the upside day. Okay. The next one is the 3. The arrival time is 3 lah, like here. The arrival time is 3, and this is the process 3. And we write down the process 3 is the burst time is 10, and the priority is 4. And we compare which one is the priority, the smallest one. The P2, right? So we use this, and the P2 will minus 1 because from here 2 to 3 is minus 1. So become 4. So the P2 is 4 and the first time is 4 and the priority is 1. So we write down the P2. Okay. The next one is which one is the arrival is the P4. The time is 5. Okay. And we write down the first time and the priority, and we compare which one first. This 4. The first one, right? The priority, the first one. Okay. So we write down the P2, and this because 3 to 5 is 2, right? 4 minus 2 is 2. So the P2 it becomes 2, the person is 2, and the priority is 1. Why we stop at the 7? Because the process 2 haven't arrived, the 8 is already done. Done at the 7 because it's less, the person is 2. So 5 to 7 is 2, right? So if you stop at the 7, and we've already done. Okay, now 7 until 8 because the next arrival time is 8, right? So we write down first and we minus the next one is P4. The lowest priority is 2, right? So we minus this one. So 7 until 8 is 3 to 2. And then the next one, the 8 will become the 2. The first side is 2 and the priority is 2 for the P4. We can write down the P5 from the process. The arrival time is already come, right? From the here, the 8. The arrival time is already, the P5 is already arrived. And we can write down 6 and 5. The first time is 6 and the priority is 5. And we compare which one is the smallest one. The 2 is the smallest one, right? And we stop at the 10. And we will done the process 4. And then the next one is, which one is the smallest one? Is a P1, right? The first time is 6. So we stop at the 16. We will done the P1. And then the next one, the smallest one is the P3. So the first time is 10, right? So we will stop at the 26. The P3 will done. Okay. And the last one is the P5. P5, the first time is 6. And we stop at 32. So the P5 will done at the 32. This is the last one. Okay. Now I will talk how to calculate the waiting time. The first one is we must always minus the arrival time for the first one. Like this T1, the arrival time is the 0, right? So the 0 here minus the 0. 0 minus 0 is the 0 ms. Okay, this is the arrival time. And now we look at the table. Got one more at here. Is the 10, the second one. And we minus the last number for the process. Is the for the second line. Minus here. The P1 here and the P1, right? We take the earliest one and minus the latest one for the first one. So the 10 minus 2 is 8 lah. So we get the MMS. So we add the two of them is the 0 and the 8. So become ms at millisecond. Okay. Okay. Now we calculate the process two. The table got three process two, right? And we combine. We take the earliest one. It's two, right? So we use the two minus the two. Why did it become two? This is arrive from the arrival time for the table, for the question, the table. So we minus become zero lah. So the P2 is 0 millisecond. Okay, the next one is process 3, right? We use the 16 minus the arrival time is 3. So we get the 13 millisecond. And the process 4, from here, we take the earliest one, the 7. Got 2 right, here and here. The 7 until 8, 8 until 10. We take the earliest one is the 7. And we minus the arrival time is 5. So we get the 2 millisecond. And the process 5 from here, the 26. So we use the 26 minus the arrival time is 8. So we get the 18 millisecond. The last one is the average for the waiting time. We add on all the calculation from here, like 8, 0, 13, 2, and 18. We calculate all and we divide by 5 because got 5 process. So we will get the last answer is 8.2 millisecond. That's all for my presentation. Okay, now I will pass it to my friend Gan Shenbing to talk about the chapter 6, the part 1